Hello, my viewers. Welcome once more to my YouTube channel, to J's Physics Lecture Series. Here I'll be talking about Kirchhoff's laws, how to analyze circuits using Kirchhoff's laws. Now, when we come across some complex circuits and you want to find the currents flowing in the circuits and also possibly the potential drops, you have to apply Kirchhoff's laws. There are both of them, Kirchhoff's current law and the Kirchhoff's voltage law. Once you can apply these two laws correctly, then analyzing any complex circuit will be actually very easy. So start with the current law, Kirchhoff's current law. This is Kirchhoff's current law. That law tells us that the sum of the current entering a junction is equal to the sum of the currents leaving that junction. In other words, if you have a junction in a circuit, the quantity of current that enters, the amount of current entering that particular junction, will be the same amount of current that will leave the junction. This current law is actually a statement of charge conservation. Like I said earlier, what implies or what the implication of this is that whatever amount of current that enters a particular junction in a circuit or a point in a circuit must be equal to the amount of current that leaves that same point. Why? Because charge cannot build up at a point. Charge does not build up at a point, and we know that current is the flow or the movement of charges. We can illustrate Kirchhoff's current law as schematically represented in the figure. Here you have, this is a junction. This is a junction. You can see it's well labeled. This is a junction. When we say a junction, we are talking about a point in a circuit where current can split. You see this current I1, the direction is to your right, so it's moving towards this junction. Either you call it a junction or you call it a node. It's moving towards this junction, and when it gets to this point, which is the node, it will split into two halves, two parts rather. This is I2 moving in a different direction. This is I3 moving in a different direction. Now what we are saying is that I1 is the total current entering here. Splitting now into two parts. These two parts must be equal to the initial current entering the junction. So mathematically we can represent this by saying I1 is equal to I2 plus I3. So when you come across a complex circuit, the first thing you do is to apply Kirchhoff's current law. When you apply that current law, it gives you an equation for all the currents flowing in that circuit. Then you move on to apply the voltage law. What does that law state? The law tells us that the sum of the potential drops across every element or each element in a closed circuit or a closed loop is equivalent to 0. This law is actually a statement of conservation of energy. The implication is that any charge that moves around a closed loop will start from a particular point and also end at that same point. So whatever energy it gains will be equivalent to whatever energy it will lose. So these are Kirchhoff's laws, the current law and the voltage law. Once you want to analyze any complex circuit, a good knowledge on these laws helps you to simplify the circuit. Now we are going to check the next slide. We cover the points that we are expected to note when we want to apply Kirchhoff's laws to complex circuits. There are certain points that we need to note to guide us in applying these laws. If you don't know how to apply those points, then using the laws may be a bit difficult for you. It's not about knowing the laws only. After knowing the law, you have to apply the laws. And there are points that you must consider before these laws can be applied effectively. So let's look onto those points. Now, going forward, let's check some of these points to note while solving circuits using Kirchhoff's laws. First and foremost, you have to assign an arbitrary current direction to the loops separately. What do we mean by that? If you check the circuit on your right hand side, let's call this loop A. Let's call this loop A, and we call this loop B. So what we mean by assign arbitrary current directions to the loop separately, we can choose that the current is flowing in the clockwise direction or in the anti-clockwise direction. Now, in this loop A, let me assume that the current flow is clockwise. So I just draw an arrow. Let me wipe this off so that I'll have some. Well, we can go like that. I just draw an arrow like this. You can see the direction. So I have assumed that the direction of current flow is clockwise. Direction of current flow is clockwise. You can use anti-clockwise. The most important point is taking note of how to assign your positive and negative values to the different components in the circuit. So I have assumed a clockwise direction in loop A. I can also assume a clockwise direction in loop B. Like I said earlier, you can choose to assign anti-clockwise direction. You still get the same answer, provided the positive points and the negative values are given correctly. Now, we have assigned this direction now, we've taken note of the first point. Let's go on to the second point. For each battery terminal, assign positive or negative values depending on the chosen direction of current in one above. What do we mean by that? This is your battery terminal now, like the EMF, okay? Since we have chosen this direction of current, arbitrary direction, it goes round, meaning it will come through this point like this. So it enters through this point and leaves through this point. Now, how do we know the positive terminal? How do we know the negative terminal? You can see from this battery that you have a longer point here, a longer line and a shorter line. This longer line is assigned the positive terminal, and this shorter line is assigned the negative terminal. So we've taken note of point 2. For each battery terminal, assign positive or negative values depending on the chosen direction of current flow. But then the long side is the positive terminal, the short side is the negative terminal. Then if the current flowing in a resistor, that's point 3, is in the same direction as the direction assigned in one above, the potential drop across the resistor is negative. What do we mean by that statement? We have assigned a direction of current in the clockwise direction as taken note by point 1. Now we check the resistor. This current flowing through the resistor, where is it flowing to? Where is it flowing to? It is flowing towards your right, which is in the opposite direction of this arbitrary current flow we have chosen. Since this I1 is moving in the opposite direction of what we have assigned originally, then the potential drop here is positive. So for this loop A, we will have plus I1 arrow 1. We continue moving to the next point. If you get to this point, we say that if the direction assigned, I'm looking at 5, we'll come back to 4. If the direction assigned in 1 above flows through the EMF source from the positive terminal to the negative terminal, then the potential drop is negative. This direction we chose is moving around. Remember, it comes through this terminal, it comes through the positive terminal and leaves through the negative terminal. Since it is leaving through the negative terminal, the potential there is negative. So we say minus E1. We come to this resistor. If you take note, this I2 is actually coming from this direction. So I2 is what is passing through the resistor R2. Since this direction we chose is also in the direction of I2, the potential drop here will be negative. So we say minus I2 R2. And of course, we move on to this point and we see that the direction is entering through the positive terminal and leaving through the negative terminal. So it becomes minus E2. And we say the sum of the potential drops, the algebraic sum of the potential drops across a closed loop is equal to 0. That is a statement of Kirchhoff's voltage law. So we say equal to 0. You've gotten one equation. You go on to the second loop, loop B. Remember here in point 4 we said if the current flowing through the resistor is in the opposite direction as assigned in 1 above, the potential drop is positive. But if the current flowing in that resistor is moving in the same direction that we chose in 1 above, then the potential drop will be negative. That's point 3. So coming back to this loop B, we'll start from here. We can start from any point, starting from R3, but always remember the direction of the current flow. This I3 is entering R3. So the current in R3 is I3. Now this current, this direction we chose is clockwise. This direction we chose, the arbitrary direction, is moving in the same direction as the current in R3. So since they are moving in the same direction, the potential drop there will be negative. So we say for loop B, we have minus I3 R3. We move on around, you must go around the circuit. So at this point, we see that the current, the direction we chose, current is entering through the negative terminal. This small line is the negative terminal and is coming out through the positive terminal. Therefore, the potential here is positive. So we say plus E1. Then you can check here in this loop. Please, when you are solving, always make sure that the loops are treated independently. That you have used I1 and R1 in loop A does not imply you will ignore it while working with loop B. Loop A is separate, loop B is separate, and this resistor cuts across both loops, so they must be treated differently and separately. So going through this resistor, we can now see that this arbitrary direction we chose is now moving in the direction of I1. Is now moving in the direction of I1. So the potential drop across this resistor will be negative. So we say minus I1 R1. Since we have finished with all the elements, remember Kirchhoff's voltage law that says the summation will give us what? 0. Then we can also apply the current law, KCL. If we apply that law, you check the diagram and see where that law fits, where it can be applied. If you check, you discover that we have I1 is entering the junction C or the node C. I2 is entering node C and I3 is going out. And Kirchhoff's current law states that the sum of the current entering a junction is equal to the sum of the current leaving that junction. So if that is the case, which we agree, then how many currents are entering the node C as in point C? Two of them, I1 and I2, are entering while I3 is leaving. So it implies that I1 plus I2 is equal to I3. So applying Kirchhoff's current law, we say I1 plus I2 is equal to I3. So we have been able to apply Kirchhoff's current law and Kirchhoff's voltage law to bring out equations for calculating the current and the voltage. Now, what we do after getting these equations, the next thing is to solve them simultaneously. Solve the equations simultaneously, then you proceed to get I1, I2, I3, E1, E2, as the case may be. Of course, if we have a diagram, if we have a circuit, we'll be given the voltage. So for E2, you have a value. For E1, you have a value. Then, for R1, R2, R3, you also have values for them. So what you do, you use this law, apply both laws to calculate the values for the currents that are flowing in the circuit. So you know the particular value of current that flows through R1, the current that is going through R3, the current that is going through R2. So let's consider one of such examples, or more. We'll consider more than one example. We'll look at a number of examples analyzing Kirchhoff's laws, so that when we come across complex circuits, we should be able to handle them applying these laws effectively. So I'll be taking some examples on this. Please remember to like my channel, subscribe to my channel for more notifications, so when I upload new videos, you are able to get those videos and follow immediately. Drop your comments in the comment section. If there are areas you want this lecture series to be improved, please, your constructive criticism will very much be appreciated. So let's consider this single loop circuit first before we consider more complex circuits. For this single loop circuit, we have two external resistors. One is 3 ohm, the other is 2 ohm, and you have two sources of EMF. One is 7 volts, the other is 2 volts. We have to find the value of the current in the circuit. Now you can see the direction of I in the circuit. You can see I've chosen this arbitrary direction following the points we listed earlier on. So this is coming from the negative terminal, entered through the negative terminal, and is leaving through the positive terminal. So the potential here will be positive. So using our equation, we say 7 volts. Coming through, you can see the direction of the current is in the same direction as what we have assigned, So the potential drop here is going to be negative. So it will now be minus, we know that V is equal to IR. So the potential in this resistor, the potential across this resistor will be I times 3, which is 3I. Coming through this point, we can also see this is the direction of the current. It will go around, so it's moving like this. We have chosen a direction, a clockwise direction. So this enters through the positive terminal and leaves through the negative terminal. So we have minus 2 here, minus 2. Then, of course, I is moving also in this direction. And we chose a clockwise direction also. So the potential drop here is going to be negative. So we say minus 2I, all equal to 0. So 7 minus 3, 7 minus 2 is 5. Minus 3I minus 2I is minus 5I, equal to 0. We take like terms to different sides of the equation. We have that 5 is equal to 5I. How did we get 5I? Since you have 0 here, you say 5 is equal to, when this 5 crosses this equality sign, becomes positive. So you have 0 plus 5I. So from this equation, we can see that I is equal to 5 all over 5, which is 1 ampere. So the current I in this circuit is 1 ampere. In subsequent examples, we'll be looking at more complex circuit. This is just a single circuit. In the coming examples, we're going to look at more complex circuits comprising of maybe 2 loops or more. And we'll use Kirchhoff's law to resolve such circuits. So remember, like I earlier said, please remember to like my channel, subscribe to my channel so that you can get notified when new videos are dropped, and also drop your comments in the comment section. Thank you.